So now you know the 8 circle theorems. Well, now let's put what we've learnt to practice. So first question is we're given what O is. It's the center of the circle. We're told that this angle's 72 and this one's 61. So work out what X, Y, and Z are equal to. Okay. Well, let's take a look at X first, right? What do you notice about it? That's a tangent, but what's attached to it? It's a triangle, isn't it? So therefore, we can say that because of alternate segment theorem, right, X is equal to 72. Yeah? All we're doing is we're doing the alternate segment theorem. Now, Y is a little bit more challenging, but let's see what we can do. What do you notice about Y? Or more specifically, the shape that Y is on? Exactly, it's on a quadrilateral. A cyclic quadrilateral, isn't it? So therefore, we can say that because of a cyclic quadrilateral, that's meant to be a C, not a S. Right? We can say that 61 plus X plus Y is equal to 180 degrees. Okay? And we know what X is. X is 72. So what's 61 plus 72 plus Y equal to? 180. This means that 133 plus Y is equal to 180. And so therefore Y is equal to 180 minus 133, which is equal to 47 degrees. Yeah? So now how are we going to work out what Z is? Well, once again, as I like to say, look at Z and look at specifically where Z is. What do you notice? Well, Z is on the center of the circle. So if I say that Z is on the center of the circle, right? Z is just equal to 2x, which is equal to 2 times 72. And so therefore Z is equal to 144. So all we've done is use 3 circle theorems, and now we've worked out 3 different angles. So now how are we going to do something like this? Here we're told that all of these points here are on the circumference. We're told that these 2 are tangents. And we're told this is 40 and this is 75. How are you going to find out what ODC is? Okay, ODC is this angle here. So let's write it down. I'll just call it X. And now, if you don't have a clear path, I always like to say, what can you work out in order to get you to the next solution? So this 40, for example, what else can we work out from here? Exactly, we can work out what this is. This is just going to be, was it DOB? This is simply going to be 180 minus 40. Because remember, these 2 have to be right angles. And so therefore those 2 are going to equal 180. So therefore this is 140. Okay? Now, what else can we work out from this composition here? Well, remember, this is an angle on the center. So the angle at the circumference is just going to be half of that. So angle DCB is just going to be 70 degrees. You agree with me? And what else can we work out? Okay, we can also work out that this angle here, if I can actually draw it, is just going to be, how do I actually label that? DOB. But okay, yeah, I'll label it like that. So angle DOB is just going to be 360 minus 140. Okay? And that's just going to be 220. So we have two angles, right? But we still don't have x. Is there anything else we can work out? Well, remember earlier, if this is a right angle, then what is this? It's also a right angle, which means we can now work out what OBC is equal to. And that's just going to be 90 minus 75, which is equal to 15 degrees. And now it's really straightforward to work out what x is, because this is a quadrilateral, which means it adds up to 360 degrees. So therefore, x is simply going to be equal to 360 minus 70 minus 220 minus 15. And if you plug that into your calculator, or you work it out yourself, we get an answer of 55 degrees. And that is our final answer. You see? So it's not just one clear path. All we're doing is we're just finding out what each of the angles are, and then we work it out from there. So something like this shouldn't be too much of a problem. How are we going to work out what RCB is? Okay, well, which one's RCB? RCB. Well, remember what we said. This is O, and we have a radius going through a tangent. So this is a right angle. And so therefore, our angle RCB is just going to be 90 minus 34. Because RCB plus 34 has to be 90, doesn't it? Because this radius meets with this tangent. And when we do that, that's just going to be equal to 56 degrees. Okay, what about ABC? What's that going to be? Well, ABC is this angle here. How are we going to work that out? Well, again, look at what ABC is attached to. It's a quadrilateral, a cyclic quadrilateral. So we can say that angle ABC is just going to be 180 minus 143. Because this angle plus this angle is equal to 180. And so when we do that, we get an answer of 37 degrees. What about OAD? Which one's OAD? OAD. Alright, so it's this angle here. What can we do to slowly but surely work out what that angle there is? Well, what can we work out? Apart from OAD, what can we actually work out? We know this is 37. We know this angle here is 56. Can we use that information in any way? Well, we know that this angle is going to be 2 times that. So we know angle COA is going to be 2 times 37, which is just equal to 74. And now, I want you guys to really get used to this idea. If this is a radius, it means that this is also a radius, which means that OCA is a isosceles triangle, which means that OCA is equal to OAC, which is equal to 180 minus 74 divided by 2. Yeah? That's just the standard way of working out an isosceles triangle. And when we do that, we get an answer of 53 degrees. So that's 53, and this also has to be 53. But okay, how are we going to work out, though, what this angle here is? This little angle, if I draw it in green. How are we going to work out what that is? Well, again, look at this. Look at OCT. What can you tell me about it? Exactly. It's a right angle. So therefore, what is it? ACD is just going to be 90 minus 53 minus 21. Yeah? To get that angle there. Because we know this is 21, we know this is 53. And it has to be a right angle because it's a radius touching a tangent. So therefore, it's equal to 16 degrees. And then finally, if I actually draw a separate diagram to show this. This is a triangle. Sorry. That is a triangle there. We know this is 16 and this is 143. So therefore, this angle here is just going to be 180 minus 143 minus 16. Yeah? And when we do that, we get an answer of 21 degrees. And so finally, because this is 21 degrees, and let's label that, we know that OAD is just going to equal 53 plus 21. Which is just equal to 74 degrees. Yeah? So all we did, once again, is use the circle theorems that we've learned, but slowly and surely work out what this angle is. But what about something like this, where this time we're asked to prove that this isn't a diameter? Well, if it is a diameter, then this has to be a right angle. So we have to show that this isn't 90 degrees. Okay? So how can we do that? Well, let's first and foremost see what we have to work with. If this is 27, then this also has to be 27, doesn't it? Because of the same segments theorem rule. Okay? How are we going to work out what this angle here is equal to, though? Well, remember, this is equal. So therefore, angle XPS is just going to equal XSP, which is just equal to 180 minus 50 over 2, which is equal to 65 degrees. Now, if this is 65 degrees and this is 27, what is the angle at the circumference going to be? Well, the angle at the circumference, or QPS, is just going to be equal to 27 plus 65. Okay? So therefore, when we work that out, we get an answer of 92 degrees, which is not equal to 90 degrees. And so therefore, QS is not a diameter of a circle, because otherwise it should be equal to 90 degrees. Thank you guys for watching. I hope this video made sense. If you guys liked it, please consider subscribing. Helps out the channel a lot. If you guys have any personal questions to ask me, join my Discord server and we can answer as best as I can. If you guys need any extra tutoring, please drop me an email and we can organize a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.